5 billion years from now, the Sun will swell into a red giant and swallow the Earth. 7 trillion years later, the last star in the universe will burn out. And then, the darkness begins. This is the story of how the universe dies. Not in a single explosion, but in a slow, quiet, trillion-year goodbye. Before we begin, a warning. Nothing you are about to see is science fiction. Every event in this journey is written into the laws of physics, and the countdown has already started. Sit back, because you are about to witness the end of everything, and the strangest part? It has already begun. Our story begins close to home. In about 5 billion years, the Sun will exhaust its hydrogen fuel. Its core will contract, and its outer layers will balloon outward until the Sun becomes a red giant, 100 times larger than it is today. Mercury and Venus will be swallowed instantly. Earth's oceans will boil away, its atmosphere stripped, its surface turned to molten rock. The Earth will not explode. It will simply be vaporized, its atoms scattered across the inner solar system like dust. Then the Sun will shed its outer layers in a beautiful planetary nebula, leaving behind a white dwarf, a dense, cooling ember the size of Earth, holding half of the Sun's original mass. Our Sun, the source of every sunrise in human history, will spend the rest of eternity as a fading crystal. The outer planets will survive the red giant phase, but their fate is grim. Jupiter and Saturn will drift into the darkness, their atmospheres slowly freezing. The Kuiper belt and the Oort cloud will remain as ghostly relics of a solar system that once cradled life. But there is a strange consolation. As the Sun fades, the white dwarf will continue to glow, a diamond-like ember radiating heat for 10 billion more years. Long after Earth is gone, the white dwarf will still shine, a faint monument to the star that gave us life. And in the cold dark between the planets, the frozen husks of the gas giants will keep orbiting, monuments to a solar system that once burned with light. Zoom out, and the same story plays out across the entire galaxy. Over the next 100 trillion years, star formation will grind to a halt. The gas clouds that birth new stars will be exhausted, and the last generation of stars, small, dim red dwarfs, will slowly flicker out, one by one. The night sky, once blazing with billions of stars, will fade to almost complete darkness. Only the faint glow of cooling white dwarfs will remind the cosmos that light ever existed. This is the beginning of what astronomers call the Degenerate Era, when the universe is ruled not by stars, but by their silent, cooling remains. But the white dwarfs have one last surprise. As they cool over billions of years, their interiors crystallize, turning into cosmic diamonds the size of planets. Astronomers have already found one, a crystallized white dwarf called BPM 37093, known as Lucy, a diamond 1,000 trillion carats. In the far future, the universe will be filled with these glowing gems, drifting through the dark like lanterns of a dead age. Each one a tombstone for a star, each one a monument to the light that once was. It is one of the most beautiful endings imaginable. During the Degenerate Era, the universe belongs to the leftovers. White dwarfs, neutron stars, and black holes drift through an ever darker void. Occasionally, two stellar remnants will collide in a burst of light, the last fireworks of a dying cosmos. Some of these collisions will forge new heavy elements, scattered into the emptiness. But no new stars will ever form from them. The raw material is gone. The cosmic cycle of birth and death, which has run for 100 trillion years, is finally complete. From now on, the universe only cools. For trillions of years, these rare collisions will flare and fade, until even they fall silent. But even the monsters will not last forever. In 1974, Stephen Hawking showed that black holes slowly leak energy through quantum effects, radiation now named after him. A black hole the mass of the Sun would take 10 to the 67 years to evaporate completely. A supermassive black hole, like the one at the center of the Milky Way, would take 10 to the 100 years. But eventually, every black hole in the universe will evaporate, releasing a final burst of radiation before vanishing forever. The last great structures of the cosmos will dissolve into nothing. And the very last of them all? The most massive black holes, the giants that weigh billions of suns, will be the final objects to vanish from the universe. They will outlive every star, every planet, every civilization that ever was or ever will be. Their evaporation is so slow that a single one of these monsters will spend more time dying than the universe has so far existed, 1,000,000,000,000 times over. When the last black hole finally flashes away, the universe will contain no more structures at all. Only particles, drifting in the dark. The age of matter is over. The age of pure radiation begins. After the black holes are gone, the universe enters its strangest phase, the dark era. If protons decay, as many grand unified theories predict, then all remaining matter will slowly dissolve into radiation. Every atom and every corpse, every rock, every remnant will simply fade away, over a timescale of 10 to the 40 years. What remains is a thinning soup of elementary particles, electrons, positrons, neutrinos, and photons, drifting through an ever-expanding void. The universe becomes a ghost, vast, cold, and nearly empty. This is the heat death, the final state toward which everything has been moving since the first moment of time. But the most patient force in the universe is dark energy. For the past few billion years, it has been accelerating the expansion of space. In the far future, every galaxy beyond our local group will recede beyond our cosmic horizon, moving away faster than light itself. The observable universe will shrink until only our own galaxy remains visible. And as dark energy continues to dominate, even the local group will eventually be torn apart. First the galaxy clusters, then the galaxies, then the stars, then the atoms. The universe will become an infinite, featureless void, expanding forever into nothing. Every map of the cosmos will be erased, one by one. But wait, there is a darker possibility. Some cosmologists argue that the strength of dark energy may grow over time. If it does, the universe will not simply fade away. It will be ripped apart in an event called the Big Rip. In the final moments of existence, galaxies will be torn apart, then stars, then planets, then atoms, and finally, the very fabric of spacetime itself. The universe would end not with a slow fade, but with a violent, catastrophic shredding. Which fate awaits us? We do not yet know. But either way, the end is written into the laws of physics. There is one more endgame, and it is the strangest of all. The quantum vacuum, the fabric of empty space itself, may not be perfectly stable. Our universe could be sitting in a false vacuum, a state that looks stable but is actually on the edge of collapse. If a true vacuum bubble nucleates anywhere in the cosmos, it would expand at the speed of light, rewriting the laws of physics as it sweeps through. Everything we know, every atom, every galaxy, would be destroyed in an instant, replaced by a new universe with different physics. This could happen at any moment. We would never see it coming. The end of everything could arrive faster than a heartbeat. But before the universe fades, consider this. We are probably not the only intelligent life that will ever exist. The last civilizations of the cosmos may emerge in 100 trillion years, around the final red dwarfs, the last stars ever born. These distant minds will look up at a nearly empty sky and wonder if they are alone. They will have no way of knowing that galaxies once filled the heavens, or that a species called humans once walked a blue planet around an ordinary star. The greatest secret of the universe, that it was once full of light and life, may vanish with the last star. Perhaps, in some way, they will remember us. Perhaps not. In the end, what remains? A universe of photons and neutrinos, cooling forever toward absolute zero. A universe that has reached maximum entropy, the heat death. No energy gradients, no complexity, no change. Time itself becomes meaningless, because nothing ever happens again. But here is the beautiful paradox. We exist in the brief, golden window between the Big Bang and the long darkness, when stars burn, galaxies collide, and life can wonder at the sky. The universe we live in today is a miracle of timing. We are the lucky ones, born in the only age where any of this could be seen at all. So why think about the end of everything? Because knowing that the universe dies makes our time in it infinitely more precious. Every sunrise, every star you see, every moment of consciousness, these are rare gifts in a cosmos that will one day hold none. The end of the universe is not a tragedy. It is the reason the beginning matters. We are the universe's way of looking at itself, a brief, brilliant flicker of awareness between two eternities of darkness. And that flicker, however brief, is enough. The universe is dying, slowly, beautifully, inevitably. But it is not dead yet. We still have time to explore, to discover, and to wonder. If this journey through deep time sparked something in you, subscribe to AstraPelagos, new cosmic journeys every week. And tell us in the comments, which ending do you think awaits us, the slow fade, the big rip, or the vacuum collapse? See you among the stars.